Hey, welcome back to BazAI. Today we are going to break down NVIDIA's Nemotron 3, a hybrid mixture of expert model family that is literally built for multi-agent AI. Imagine you are running hundreds of agents in parallel, planner, tool callers, evaluators, all reasoning over a 1 million token context without melting your GPU or your cloud bill. That is exactly the problem Nemotron 3 is trying to solve. And in this video, a full technical walkthrough of how the hybrid Mamba Transformer mixer of expert architecture works, why active parameters per token matter more than just saying 500 billion model, and where Nano, Super, and Ultra actually fit in real multi-agent systems you might build. Grab a coffee. This is deep dive, not a hype reel. What problem is Nemotron 3 solving? Let's start with the plain. Modern agentic systems are not a single chatbot anymore. You typically have a retrieval agent, a planner, one or more tool calling or coding agents, a verifier, or judge model. All of them talk to each other, all of them write a shared memory, and all of them extended the context window every time they speak. The result? A communication overhead explodes. Context window fills up, and your GPU bill goes vertical. The traditional dense LLM are not designed for this. They active every parameter for every token, whether the token is doing the complex reasoning or just passing the message along. Neutron 3 says let's keep the capacity of a big model, but only pay the computations on a small slice of for each token. So Neutron 3 family of open model, the Nano, Super, and Ultra, they are built around this hybrid Mamba Transformer MoE backbone. The Nano, the around 32 billion total parameters, but only activated 3 billion per token, and Super, roughly 100 billion total, but about 10 billion active per token, and Ultra is 500 billion total, and it's activate 50 billions per token. Think of it like Nano is high throughput worker model for spamming lot of agents, and Super and Ultra are the heavyweight planners, verifiers, and long horizon reasoners. All of them target a context window up to 1 million token, which completely changes how you design a long running agent workflow. Now let's understand the backbone of it and how Nemetron 3 integrate all these three components. The Mamba layer for ultra efficient sequencing modeling over huge context, and transformer attention layer for precise fine graining the reasoning, mixture of expert layer for scale capacity without paying for every export on every token. For Nemetron 3 Nano, the technical reports is 23 Mamba 2 layer plus mixture of experts block plus handful of attention layers totaling 31 billion parameters with 3.2 to 3.6 billion active for every forward pass. What does active per token means? Let's imagine you have a big model and it only activates certain experts within the big model. So you can have the specialized agents or experts to agents to communicate only wakes up when routing says this token needs you. So instead of like one gigantic dense brain, you get a cluster of small expert brains, and each token only consult a few of them. And how this expert routing gonna works, let me zoom in the mixture of expert layer, because this is where a lot of magic happens in a pipeline. How it's gonna, if you give a prompt, the token get embedded and pass through the shared backbone layer, and the router looks each token representation and scores for each expert, and it picks the top expert. For example, 6 out of 128, it sends the token representation only to that expert. So you can imagine, if you go to the your college or school, if you wanted to talk to the max expert, you have to go and reach to the max lecturer. Similarly, the routing layer knows which particular expert it has to invoke depending upon the prompt comes in, and where you put your equation out there, and inside the expert, the agent can use a multiple agents with different reasoning and multiple step planning. The training everything gonna be include the load balancing losses, and it regularize the expert. So it means you don't need to activate the entire the huge dense brain to consume the compute. It's only take the smaller brain, the export, and then activated them with a lesser cost, and it has a huge contextual memory, which is how the Mamba 2 layer is going to work it here. And the computational cost is lower because I'm only activating certain expert. Now it comes to why we need the Mamba here. Mamba 2 is a sequence model that gives you a linear time scaling. So it means it keeps track of long range dependencies with much lower memory. So Nemotron 3 on the Mamba to handle the massive 1 million token contextual window without exploring the cache, which means it understands entire code base, sit in the context, the whole investigation timeline or incident report can live in a single window. Cross agent messages stay inside the model, not scatter across the external store. Instead of playing a heavy tool to go to the RAG models and get the agents operating it within the agents, it shared that huge contextual information with a shared memory that allow the Nematron 3 to respond much faster. And Nematron 3, this is not only the thing, it has a multi-environment reinforcement learning and reasoning controlling. So which enable NemoGym and multi-environment reinforcement learning align this model to use the tool usage, multi-step planning, code generation to actually runs. And the oral dataset include the trajectories for the agent workflows, tool calling sequences, verifiable outcomes, just not one slice of it. You can on and off toggle your reasoning. You can enable the thinking budget to control your reasoning tokens, allow them to spend. It's you get a very cheap model with minimal reasoning that enable you to have uh, a better uh, open source agentic multi workflow agentic LLM model in behind, and it's perfectly suitable for multi agent workload, and it has a massive throughput and massive context scoring capabilities. That's where Nematron is top notch when compared to Nematron 2 Nano. It's performed 4x higher tokens, and thanks to the hybrid Mamba and mixture of exports, reduce the KV caching and enable it to have a 1 million token context, so you can keep long running histories and multi documents in Windows, and this agent works in parallel without blocking each other. You can generate a reasoning token, avoid the agentic looping amplification. This enable the perfect planner worker judge architecture. Nemotron 3 Nano is very natural for this kind of a backbone for the modern agentic workflow. And it's open family, the weights, data, and training, everything is going to be available. You can download the Nemotron 3 Nano today via VLLM and Hugging Face, and you can start this, understand the data sets, how it's been trained, and you can utilize this Nemotron 3 on a platform like NVIDIA's NEM and microservices to the cloud providers, which already integrating this model. This enable you to work for tool heavy workflows and code and data ops agents and with the reasoning capabilities. Nano is perfectly suitable for background reasoning over long logs and traces. If you have the huge chunk of the data, which is required to you to have a tool heavy workflows, Nano is perfectly good for you. And if you wanted to have a global planner orchestration, policy judge, and high stake decision maker for top notch, it's super and ultra is perfectly fine. As it's open source, you can fine tune for your models, you can fine tune for your agent trace, evaluation, the logs, and internal tooling capability, tighter alignment for your specific workflows. So, Nematron 3 is really a big shift towards the agentic world. So let me recap in one line. Nematron 3 is NVIDIA's attempt to make big open model actually practical for the large, noisy, multi-agent systems by mixing Mamba Transformer and mixer of experts into single efficient backbone. And if you want to follow up where a full multi-agent stack is wired using Nematron 3 Nano with planner, tools, and evaluation loop, drop me in a comment and hit me like and subscribe to the BazAI and share this with someone who really currently burning those GPUs and dense models for agent workflows. Thanks for watching.